Hello, and welcome. My name is Mischa Johal. I'm a grade 12 student in the John Oliver Digital Immersion Mini School, and here is my 2020 IDS project. Before we start, yes, I am recording this on my laundry room. That's exactly why I'm moving out for university. Anyway, I'd like you to consider the following. Imagine you're at a crowded party, packed to the brim with people all chattering with their friends. While this is going on, you're trying to have a conversation with your friend about why in the hell there'd be a party in this gigantic global pandemic. And you can hear your friend all right. It's not great, but you're able to catch enough to be able to formulate a response to whatever your friend's saying. Now, imagine you hear someone behind you talking about Amber's new boyfriend who just got drafted for a professional football team, and without turning around, you perk up your ears to listen in on some juicy gossip for a couple seconds, and then focus your attention back on what your friend is saying. What you just did there might seem simple, but in fact, the ability to be able to focus in on a specific sound in a room full of otherwise conflicting sounds, known as the cocktail party effect, is one of the most amazing abilities we as humans have. Apart from, of course, being able to touch our toes while standing up. Still haven't quite figured that one out yet. So, why have I chosen this for my IDS this year? Well, because of my genetics IDS, flashback to 2018, I'm probably going to go mostly deaf in my left ear by the time I'm 30. I've realized this because of that project. See, IDS does carry over between the ears. Now, I'm not alone. Millions of people around the world are deaf, and millions more are going to go deaf, be it as a result of genetics or, pushing those earbuds in too hard into your ears. Be careful. Now, an obvious solution for this, you might think, is hearing aids, right? They're everywhere. You see commercials on TV. Great. Well, no. It's not that simple. Aside from the massive expense that isn't covered by medical plans, sometimes, hearing aids basically just amplify everything around you. Yes, there are some hard-coded filters. However, these do very little to actually improve speech intelligibility. Think about it this way. Let's say you're a hearing-impaired person walking with your friend in a downpour, and because you're struggling to hear, you turn your hearing aid on. Well, this means your friend's voice is amplified, but it also means everything else around you is amplified too. The rain, the sound of the cars, the shoes on the pavement. Everything is amplified. Hearing aids don't really help unless they are active in an isolated environment, where there's just really one other dominant sound, like you and me talking in a room alone, let alone in the party, that I first mentioned. Never going to work there. Okay, now that we know the problem, we can go about solving it. After researching online and looking at some GitHub repositories and finally emailing Dr. Eric Healy at the University of Ohio, I realized that this project I'd chosen was kind of the holy grail of speech processing. So, no pressure there, right? It's going to be easy to solve, of course. So, I'm going to go through the successes I've had, challenges I've come across, where I'm going to go from here. Because it's a pretty awesome project. I think one of the most exciting I've done yet. Short disclaimer first. I could explain parts of the neural network I've programmed and the mathematics behind the algorithm and, show you some cool pictures, but really, honestly, the kind of in-depth information I need to give you so that you'd be able to understand this and follow along as we have this discussion would be probably a 30-minute video, let alone a 5-minute one, and I'm just not going to do that. Not going to try that. So, I'm going to keep it brief, keep it interesting. I'll include some links to my GitHub Repo and Google Doc research in the comments below. If you'd like to learn more, click on those. There's a lot of resources in there, and you can follow along with the progress I'm going to have with my project over the course of the summer. Okay, ready? Here goes. Initially, I used a short-time Fourier transform in combination with spectral subtraction methods to digitize the filtering of a noisy speech signal. This gave me reduced signal-to-noise ratios, however, did not significantly improve speech intelligibility, and worse, would never work on a live basis, as speech is constantly evolving over times and environments. After this, I found several extremely important papers written in part by Delane Wang, another professor at the University of Ohio, and who I believe is the leading expert in the world on deep learning-assisted signal processing for speech enhancement. These led me to what I've been working on for the last couple months, or last couple weeks really, months with research, weeks with coding, as it always is, And I believe to be able to finish this project sometime mid-summer towards the end of summer and continue working on it from here and upgrading and improving on what I can. Wang's paper proposed using an ideal binary mask in combination with a linear, deep neural network to filter a noisy signal, thus improving speech intelligibility for hearing impaired listeners. So here are a couple buzzwords in there if you're still with me. Deep learning, ooh, we'll get to that in a sec. It's going to be as exciting as you think it is. Now, I'm going to make a couple changes to what I just said. One, I'm not going to be using an ideal binary mask. I'm going to use an ideal ratio mask. I'll use a convolutional neural network programmed with Keras instead of a recurrent neural network. Takes up a lot less memory, is a lot faster, is actually better. And once I have a trained model, I'll be implementing this in a live fashion on a Raspberry Pi-based hearing aid system. But that's a lot later down the road. So far, right now, I've come across some challenges. First, I don't have a master's degree in signal processing. This means I can't understand most of the math behind the theory of signal processing, limiting me in terms of what I can create on my own versus what I can on the base of others' research, specifically in terms of speech intelligibility. Coding, still good with that. Number two, I do not have a powerful enough GPU on a Windows-based system. Cloud computing exists, fortunately. However, for someone like me who likes to learn by running models and kind of seeing the changes between the two, free credits I'd like to get with like Amazon Web Services or something like that would run out pretty quickly before I actually got to training my final model. A lot of the challenges I've had in terms of resource gathering and organization and the scope of the project have actually been solved using the knowledge I gained during my grade 10 IDS. Ooh, another flashback. Building a portable DNA sequencer. From this one project, I gained huge knowledge in terms of reading scholarly articles, creating goals for projects, understanding the limitations of certain systems, and knowledge bases. And I'm learning a lot right now, which I'm sure I'll apply to projects later on in university and down the road. Finally, where do I go from here? Well, into the summer. This is a fascinating project that might benefit thousands of people around me directly one day, including myself. So apart from this being extremely engaging and providing me with ample opportunities to stay focused and learn new concepts and skills, I might just improve a little bit of the world as well, which I think should be the goal of every single IDS. Great, that's about it for this. Bit over time, not gonna lie, sorry Miss Inc. However, I hope you guys follow along with me. Again, resources down below in the comments. Please check it out. I'll see you guys later.